Welcome to our video presentation. So in this video, we are going to discuss about centrifugal pumps. So what is centrifugal pumps? Centrifugal pumps are mechanical devices widely used to transport fluids by converting mechanical energy from an external source, such as electric motor, into kinetic energy in the fluid, using a revolving impeller that generates a low pressure zone at the pump center. They work on the centrifugal force concept, drawing fluid in through the suction port and releasing it through the discharge port. The shaft, which connects the impeller to the motor, the casing, which directs the fluid flow, and the impeller, which transfers energy to the fluid, are the three primary pieces of a centrifugal pump. Because of their efficiency and versatility, centrifugal pumps are crucial in a variety of industries such as food production, water treatment, chemical processing, and agriculture. They are a popular option for many applications where fluid movement is necessary because of their capacity to manage enormous volumes of liquid at different pressures.
Here are the main components of a centrifugal pumps and their roles. First, discharge nozzles. This is where the fluid exits the pump after being pressurized. Second, radial bearing. Radial bearing supports the shaft and ensures smooth rotation. And then thrust bearing. This prevents the shaft from moving forward or backward during operation. And then we have shaft key. Shaft key locks the impeller and shaft together to ensure they rotate as one. And then shaft. Shaft connects as the motor to the impeller and transmits energy for rotation. Meanwhile, bearing housing is to protect and hold the bearing in a place for stability. And then we have side glass. Side glass is a small window to check the oil level for proper lubrication. And then we have mechanical seal. Mechanical seal helps to prevent leaks by sealing the rotating shaft and the stationary casing. And then we have impeller. Impeller is the main part that spins and increases the fluid speeds and pressure. And then we have suction nozzle. Suction nozzle is a place where fluid enters the pump before being pressurized by the impeller. Meanwhile, casing, it surrounds the impeller and directs fluid from suction to discharge. And then lastly, we have centerline mounted supports to keep the pump stable and reduces vibrations. So now, let's discuss the main components of a centrifugal pump as listed on this slide. So the first one is impeller. The impeller is attached to the shaft and spins at the same speed as it. It's powered by a motor, engine or hydraulic unit. It increases the fluid's velocity and kinetic energy as the fluid enters through the center and exits at high speed through the vents. Second, we have shaft. The shaft connects the motor to the impeller and transfers energy for rotation. It must be robust, well-aligned, and precisely machined to ensure smooth operation and minimize wear or vibrations. It's made of corrosion-resistant materials to handle tough environments, which is supported by bearings for alignment during high-speed rotations. And then third, we have bearings. Bearing supports the shaft and absorb both radial and axial forces during operation. They maintain alignment, allow smooth rotation, and efficiently transmit power from the motor to the impeller. And then we have casing. The casing surrounds the impeller and the pump liquid. It has a specific shape that guides the flow of the liquid as it exits the impeller. The casing's geometry is crucial for pump efficiency and can be one of the value of diverser type, depending on applications in sectors like nuclear and desalination. So now, let's dive into how a centrifugal pump operates. The process can be explained in four main steps. The first one is impeller rotation. First, the motor drives the impeller, making it spin at high speeds. The impeller's rotation generates kinetic energy, which is transferred to the fluid. Second, fluid entry. The fluid enters the pump through the impeller's eyes, which is at the center. Due to centrifugal force, the fluid is pushed outward and its velocity increases as it moves toward the edge. Third, pressure generation. As the fluid moves outwards, it creates a low pressure area at the impeller centers. This low pressure draws more fluid into the pump. Meanwhile, the fluid's kinetic energy is converted into pressure energy in the casing. And then, lastly, fluid discharge. Finally, the pressurized fluid exits the pump through the discharge outlet, ready to be delivered to its destination. In short, centrifugal pumps operate by transforming rotational energy into fluid energy, ensuring the smooth and efficient fluid movement.
Next is the application of centrifugal pump in food industry. First, liquid transfer. One of the primary uses of centrifugal pumps is to transfer liquid efficiently from one part of the production process to another. In the food industry, these include handling liquids like fruit juice, soups, dairy products, oils, and even broths. This pump ensures a consistent flow rate, which is critical for maintaining the quality and uniformity of the product. For example, when transferring milk in dairy plant, centrifugal pumps ensure that it flows smoothly without causing frothing or damage to its structure. Next, food and beverage production. Centrifugal pumps are integral to many stages of food and beverage production, such as pasteurization, filtration, mixings, and bottling. For instance, during juice production, these pumps help move the juice through pasteurizer to ensure it's heated evenly and safely. They are particularly effective for low viscosity liquids like syrups or carbonated beverages, ensuring they are processed quickly and without contamination. Third, packaging operation. Accurate filling is critical in packaging operation to ensure consistent product quantities in every container, whether it's a bottle of juice or jar of sauce. Centrifugal pumps play a vital role here by delivering precise amount of liquid during the filling process. For example, during beverage bottling lines, this pump ensures that each bottle is filled with exactly the right amount of liquid at high speeds without spillage or wastage. And lastly, handling viscous product. While centrifugal pumps are best suited for low viscosity liquids, they also can handle more viscous products like sauces, batters, or purees with some modification. They ensure these thicker products are moved efficiently without clogging or damaging their texture. For example, when producing tomato sauce, centrifugal pumps help transfer the sauce from cooking vats to packaging lines while maintaining its consistency. Next, let's move on to the advantages of application of centrifugal pumps in food industry. First is sanitary design. In the food industry, hygiene is non-negotiable. Centrifugal pumps are designed with materials like stainless steel that meet strict sanitary standards set by organizations such as FDA. Their smooth surface prevent bacteria from accumulating, making them easy to clean and sterilize after use. Second, high flow rates. Centrifugal pumps are capable of achieving high flow rates, which is essential for large-scale food production operation where time is critical. For example, in a beverage factory producing thousands of liters per hour, this pump ensures that liquids are transferred quickly from one stage to another without bottlenecks in the process. Third, versatility. One of the biggest advantages of centrifugal pump in their adaptability, they can handle a wide range of liquid with different viscosities and characteristics. Whether it's thin liquids like water or slightly thicker one like syrup or sauces, this pump can be customized to meet specific needs across diverse applications. Let's move to the disadvantages of centrifugal pumps in food industry. While centrifugal pumps are highly efficient, they do have some limitations in the food industry that are important to consider. The first one is inefficiency with high viscosity fluids. Centrifugal pumps struggle when dealing with thick or viscous products like syrups, sauce, or creams. As viscosity increases, their performance takes a serious hit, making them less suitable for these types of applications. Second, not suitable for large suspended solids. Another challenge in handling fluids with large particles of suspended solids, the impeller can easily get clogged or damaged, which can disrupt the entire production process. The third one is higher maintenance for delicate applications. Finally, in food-grade applications, hygiene is non-negotiable. Centrifugal pumps often require more effort to maintain cleanliness, especially with systems like clean in place, which can be time-consuming and complex. So, while centrifugal pumps are versatile, understanding these limitations helps ensure the right equipment is chosen for specific food industry processes.
Next, let's move on into the application of centrifugal pump in chemical industry. First is fluid transfer. Centrifugal pumps are primarily used for fluid transfer within chemical plants. They efficiently move liquids from storage tank to reactor or other processing units. This continuous flow is crucial for maintaining production schedule and ensuring that there are no interruptions in the manufacturing process. The ability to handle large volume of liquid quickly makes this pump is indispensable in high-capacity operation where time and efficiency directly impact profitability. Next is handling corrosive liquid. One of the standout features of centrifugal pump is their capability to handle corrosive fluids such as strong acid and alkali. In the chemical industry, where such substances are commonplace, using pump made from corrosion-resistant material is critical. This not only protects the integrity of the pump itself, but also ensures safety by minimizing the risk of leaks or spills that could lead to hazardous situations. The selection of appropriate materials for pump construction, such as stainless steel or specialized alloys, allows them pump to operate effectively in harsh chemical environment. Next, pumping viscous fluids. Another significant application of centrifugal pump is their ability to manage fluids with varying viscosity. In many chemical processes, the materials being handled can be thick or sticky, which poses challenges for other types of pump. Centrifugal pumps are designed to maintain performance even the viscous fluids, ensuring that they can transfer this material without altering their properties or compromising quality. This versatility is essential for industries that deal with a wide range of products from adhesive to polymer. And lastly, wastewater treatment. In addition to their use in production processes, centrifugal pumps play a crucial role in wastewater treatment within chemical manufacturing facilities. They are responsible for moving effluent through various stages of treatment, including filtration and purification processes. Effective wastewater management is vital for compliance with environmental regulation and for minimizing the ecological impact of chemical operation. By utilizing centrifugal pump, companies can ensure efficient treatment and safe disposal of recycling of wastewater. Next, let's move on to the advantages of application of centrifugal pump in chemical industry. First is corrosion resistant. The construction material used in centrifugal pumps are chosen specifically to resist corrosion from aggressive chemicals commonly found in the industry. This feature not only prolongs the lifespan of the pump but also enhances safety by reducing the likelihood of leaks or equipment failures that could lead to hazardous situations. Second, smooth flow. One of the technical advantages of centrifugal pump is their ability to provide a smooth and continuous flow of liquid without pulsation. This characteristic is essential for maintaining consistent pressure throughout processing system, which help prevent disruption that could affect product quality or operational efficiency. Lastly, versatility. Centrifugal pumps come in various sizes and configurations, making them adaptable to a wide range of operational requirements across multiple applications within the chemical industry. Whether it's a small-scale operation or a large industrial plant, they are centrifugal pumps designed to meet specific needs efficiently.
Next, the disadvantages of centrifugal pumps in chemical industry. While centrifugal pumps are widely used in the chemical industry, they are not without their challenges. Let's take a closer look at a few key drawbacks. The first one is limited suction power. These pumps rely on centrifugal force to move fluids, which means they often need priming and must be submerged to function effectively. This limitation can make them less practical in certain systems or setups. The next one is sensitivity to contamination. Another concern is their susceptibility to contamination. Without proper maintenance, these pumps can pose safety risks and compromise the quality of chemical products, which is a serious issue in sensitive processes. The third one is compatibility issues. Lastly, not all centrifugal pumps are compatible with every chemical. Using the wrong pump can cause material degradation or even complete failure, putting both equipment and personnel at risk. By understanding these limitations, we can better address them and ensure centrifugal pumps are used effectively in the chemical industry.